Yes, you can use L2 and L3 to install 240-volt receptacles from a three-phase delta power source. Yes, you can use the high leg. No, some equipment can operate with one leg at a higher voltage, such as 208 volts. Firstly, the equipment must be rated for the higher voltage. Secondly, the circuit must be properly grounded. Thirdly, the circuit must be protected by a circuit breaker or fuse rated for the higher voltage. In this case, the welders are rated for 240 volts and require ground. Therefore, you can use L2 and L3 to install the receptacles, and you can use the high leg L3 for one of the hot conductors. Here are the steps to install the receptacles. 1. Turn off the power to the panel. 2. Install the receptacles in the desired locations. 3. Connect the black wire from the receptacle to L2. 4. Connect the red wire from the receptacle to L3. 5. Connect the green wire from the receptacle to the ground bus. And 6. Turn on the power to the panel. Always use a licensed electrician to perform electrical work. Make sure that all connections are tight and secure. Test the receptacles to make sure that they are working properly. Delta connections are used in three-phase electrical systems, and they are characterized by having three phases of power, but without a neutral conductor. This configuration can be found in both 240-volt and 480-volt systems, and is often used in industrial settings. The delta configuration gets its name from the way it is drawn in electrical schematics, which resembles the Greek letter delta. In a delta system, the voltage between any two phases is the same, but the voltage to ground can be different depending on whether it's a corner grounded delta, a center tap delta, or an ungrounded delta system. A high leg delta system is a type of three-phase electrical service where one phase, often referred to as the stinger leg, wild leg, or high leg, has a higher voltage to ground than the other two phases. This is usually achieved by center tapping one of the transformer windings in a delta-connected transformer bank. The voltage from the center tap to one of the other phases is typically around 208 volts in a 240-volt system, whereas the voltage from the other two phases to ground is around 120 volts. This configuration provides the advantage of having both 120 volts and 240 volts available from a single transformer bank, allowing for a mix of single-phase and three-phase loads. However, it's important to properly identify and label the high leg to avoid accidental connections that could damage equipment. The National Electrical Code (NEC) requires that the high leg be identified by orange color coding to prevent confusion. When installing 240-volt receptacles on a high-leg delta system, it is essential to understand the voltage relationships between the phases and ground. As you mentioned, you are considering using L2 and L3, with L3 being the high leg at 208 volts to ground. The voltage between L2 and L3 is 240 volts, which should be suitable for equipment rated for 240-volt operation. However, it's critical to ensure that the equipment connected to these receptacles does not require both legs to be 120 volts to ground. Most 240-volt equipment, such as welders in your industrial application, are designed to operate with a 240-volt potential between the two hot conductors and do not rely on each leg being 120 volts to ground. They simply need the specified voltage between the two energized conductors. Grounding is a critical safety aspect of any electrical installation. In a high-leg delta system, the ground wire provides a path for fault current to return to the source, allowing the circuit breaker or fuse to trip and energize the circuit in the event of a ground fault. This protects personnel and equipment from electrical shock and damage. The ground wire should be connected to the equipment grounding bus in the panel, which is then connected to the grounding electrode system. When installing the 240-volt receptacles, make sure to connect the green ground wire to the grounding terminal on the receptacle and to the equipment grounding bus in the panel. Overcurrent protection, such as circuit breakers or fuses, is essential for protecting the circuit from overloads and short circuits. The circuit breaker or fuse should be rated appropriately for the amperage of the circuit and the equipment being connected. In your case, since you are using 240-volt welders, the circuit breaker should be sized to handle the maximum current draw of the welders, taking into account any applicable dirting factors for continuous loads. Make sure to use the correct size wire for the circuit as well, based on the amperage rating of the circuit breaker and the ampacity of the wire. The National Electrical Code, NEC, provides tables for determining the appropriate wire size for different amperage ratings and insulation types. When working with electrical systems, always follow safe work practices to prevent electrical shock and injury. Firstly, always de-energize the circuit before working on it by turning off the circuit breaker or removing the fuse. Secondly, use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Thirdly, wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. Fourthly, never work alone, and always have someone nearby who can assist you in case of an emergency. Fifthly, if you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Regarding the specific steps you mentioned, they are generally correct, but let's elaborate on each one. Firstly, turn off the power to the panel. Locate the circuit breaker that feeds the circuit you will be working on and turn it off. Verify that the circuit is de-energized using a voltage tester. Secondly, install the receptacles in the desired locations. Choose locations that are convenient for the welders and that comply with any applicable codes or regulations. Use appropriate electrical boxes and mounting hardware for the receptacles. Thirdly, connect the black wire from the receptacle to L2. The black wire is typically used for one of the hot conductors in a 240-volt circuit. Connect it to the terminal on the receptacle that is designated for the hot conductor. Fourthly, connect the red wire from the receptacle to L3. The red wire is typically used for the other hot conductor in a 240-volt circuit. Connect it to the terminal on the receptacle that is designated for the hot conductor. Fifthly, connect the green wire from the receptacle to the ground bus. The green wire is the equipment grounding conductor and should be connected to the grounding terminal on the receptacle and to the equipment grounding bus in the panel. Sixthly, turn on the power to the panel. After you have completed all the wiring connections and verified that they are correct, turn the circuit breaker back on. Test the receptacles to make sure that they are working properly. Use a voltage tester to verify that there is 240 volts between the hot conductors and 120 volts from each hot conductor to neutral if the neutral is present, and check for proper grounding. Always consult the National Electrical Code, NEC, and any local codes or regulations for specific requirements and guidelines for electrical installations. The NEC provides detailed information on wiring methods, grounding, overcurrent protection, and other important aspects of electrical safety. It's important to stay up to date with the latest edition of the NEC and to follow all applicable codes and regulations to ensure a safe and compliant installation. In summary, you can use L2 and L3, including the highlight, to install 240-volt receptacles for your welders, provided that the equipment is rated for 240-volt operation and that you follow all applicable codes and regulations for grounding, overcurrent protection, and safe work practices. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Remember to properly identify the highlight with orange color coding to prevent accidental connections. Consider the specific requirements of the welders you will be using, such as the amperage rating and any special grounding requirements. Use the correct size wire and circuit breaker for the circuit and ensure that all connections are tight and secure. By following these guidelines, you can safely and effectively install 240-volt receptacles on your high-leg delta system. Additional considerations include voltage imbalance. In a high-leg delta system, voltage imbalance can occur if the single-phase loads are not evenly distributed across the phases. This can lead to overheating of transformers and other equipment. To minimize voltage imbalance, try to balance the single-phase loads as much as possible. Additionally, harmonic distortion can be a concern in electrical systems with nonlinear loads, such as welders. Harmonic distortion can cause overheating of transformers, conductors, and other equipment, as well as interference with sensitive electronic equipment. To mitigate harmonic distortion, consider using harmonic filters or other mitigation techniques. Surge protection is also an important consideration for protecting electrical equipment from voltage surges caused by lightning or other events. Surge protective devices, SPDs, should be installed at the service entrance and at sensitive equipment to divert surge current to ground. Regularly inspect and maintain the electrical system to identify and address any potential problems before they become serious. Check for loose connections, damaged wiring, and other signs of wear and tear. Perform regular testing of circuit breakers and ground fault circuit interrupters, GFCIs, to ensure that they are functioning properly. Keep accurate records of all electrical work performed, including wiring diagrams, equipment specifications, and test results. This will help with troubleshooting and maintenance in the future. Consider using energy-efficient equipment and practices to reduce energy consumption and costs. This can include using LED lighting, high-efficiency motors, and other energy-saving measures. Educate employees about electrical safety and safe work practices. This can help to prevent accidents and injuries. Provide regular training on the proper use of electrical equipment and the hazards of electricity. In addition to the technical aspects of installing 240-volt receptacles on a high-leg delta system, it's also important to consider the overall design and layout of the electrical system. This includes factors such as the location of the panel, the routing of the wiring, and the placement of the receptacles. The panel should be located in a clean, dry, and accessible location. The wiring should be routed in a manner that minimizes the risk of damage and interference. The receptacle should be placed in locations that are convenient for the welders and that comply with any applicable codes or regulations. When designing the electrical system, consider the future needs of the facility. This may include adding capacity for future expansion or upgrades. It's also important to consider the aesthetic aspects of the electrical installation. The wiring and equipment should be installed in a neat and orderly manner. The receptacle should be chosen to match the decor of the facility. By considering all of these factors, you can ensure that the electrical system is safe, reliable, and efficient. Remember to always consult with a qualified electrician for any electrical work and to follow all applicable codes and regulations. Electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. This is especially important in industrial settings where there may be a higher risk of electrical hazard. By following these guidelines, you can safely and effectively install 240-volt receptacles on your high-leg delta system and ensure that your welders have a reliable source of power. Remember that the information provided here is for general guidance only, and that you should always consult with a qualified electrician for specific advice and recommendations. Electrical codes and regulations can vary depending on the location, and it's important to comply with all applicable requirements. By taking the time to plan and execute the electrical installation properly, you can ensure safe and efficient operation for your facility.